pre-cal students. Today we're going to go over our last section that we're going to be doing in Unit 10, and it'll be in 10.5, page 628, Binomial Expansion with Pascal's Triangle and Combination Formula. So let's start off looking at Pascal's Triangle. So the reason this is fitting in this unit is because Pascal's Triangle is full of patterns, and we'll use those patterns to expand binomials. So when we talk about Pascal's Triangle, we start off with what's called row 0, and row 0 just has a 1 in it because anything to the 0 power is 1. And then the next row starts with a 1 and ends with a 1. And then to get the next row, you start with a 1 and then you add those two numbers up. So you'll have a 2 and then you end with a 1. And this is referred to as row 2. Then for row 3, we'll start with a 1. We add those two numbers, that's a 3. We add those two numbers, that's a 3, and we end with a 1. Row 4, 1. We add these two numbers, 4. Add these two numbers, 6. Add these two numbers, 4. And we end with a 1. We got 1, 5, 10, 10, 5, 1, 1, 6, 15, 20, 15, 6, and 1. Always starting with a 1 and then adding your numbers. So this is row 7. Your second number will always tell you the row number you're on. 21, 35, 35, 21, 7, and 1. So Pascal's Triangle's got all kinds of patterns. If you look down this diagonal, those are just your numbers in order. 1, 2, 3, 4. Same thing about this one. 1, 2, 3, 4, 5, 6, 7. When we look down here, we got 1, 3, 6, 10, 15, 21. Separated by 2, separated by 3, by 4, by 5. So there's just patterns all in Pascal's Triangle. For our purposes, we're going to be using them to expand binomials. Okay, let's look at our first example. So example 1. Is to use Pascal's Triangle to expand on A. We got A plus B to the 7th. And then on B, we got 3x plus 2 to the 4th. So whatever exponent it's raised to is the row we look at for Pascal's Triangle. So if I go back to my Pascal's Triangle, if it's raised to the 7th, then I'm going to look at this row, and those are going to be my coefficients when I expand my binomial. So in doing A part, if I take A plus B to the 7th, then I'm going to look at the 7th row of Pascal's Triangles. So I'm going to write down those numbers. It was 1 and 7, 21, 35, 35, 21, 7, and 1. And so I'm going to take this first term, and I say I walk it downstairs. I start here, and it'll be A to the 7th, A to the 6th, A to the 5th, A to the 4th, A to the 3rd, A to the 2nd, a to the first, no a. Then I start with this second term, and I walk up. So I start here at the end, and this will be b to the 7th, b to the 6th, b to the 5th, b to the 4th, b to the 3rd, b to the 2nd, b, and no b. If there's a plus sign in the middle, then there'll be plus signs separating all of my terms. So then my final answer, 1a to the 7th is just a to the 7th, plus 7a to the 6th, b, plus 21a to the 5th, b to the 2nd, plus 35a to the 4th, b to the 3rd, plus 35a to the 3rd, b to the 4th, plus 21a squared, b to the 5th, plus 7a, b to the 6th, plus b to the 7th. There's my final answer. As you can see, every term has a degree of 7. Like we got a 7 here. 6 and 1 is a degree of 7. 5 and 2, a degree of 7. 4 and 3, a degree of 7. 3 and 4, a degree of 7. 2 and 5, 7. 1 and 6, 7, and then 7. So it's a good way to check yourself. All right, so we got our coefficients from Pascal's triangle. We knew to look at the 7th row because of the power of 7. And then we took the first term, walked it down. We took the second term, started at the end and walked it up. Now, otherwise, if I had asked you to take a plus b and raise it to the 7th, that would mean you would multiply a plus b to itself 7 times. And you know, you can only multiply two things at once and then combine and then distribute and then combine and distribute. It's a lot of work. So using Pascal's triangle for those coefficients is very helpful. All right, let's look at B part. On B part, we have 3x plus 4, 3x plus 2 to the 4th. So because of this power of 4, I'm going to look at the 4th row of Pascal's triangle. So if I go back to my Pascal's triangle, here is the 4th row. So I'm going to use the numbers 1, 4, 6, 4, 1. So I'll go ahead and write those down. 1, 4, 6, 4, 1. This time though, my first term and my second term are not just variables. They have numbers with them, but it is the same process. So when I take this first term and I walk it down, I'd have 3x to the 4th. Notice I put the 3 and the x both in parentheses because they'll both be raised to the 4th. And then 3x to the 3rd. And then with the 6, I'll have 3x to the 2nd. 3x to the 1st, no 3x. And then for the second term, I'll start down here. 2 to the 4th. 2 to the 3rd. 2 to the 2nd. 2 and no 2. We need to look now and see if we see degrees of 4 because the second term didn't have a variable. So we got a degree of 4. 3 and 1 is a degree of 4. 2 and 2 is a degree of 4. 1 and 3 is a degree of 4, and then 2. Remember, if this is a plus sign, then plus signs will separate all my terms. So I'm going to show my work here. So this is 1 times, and then 3x to the 4th is 81x to the 4th. And then I'll come back and multiply. This is 4 times 3x to the 3rd is 27x to the 3rd. And then you have that 2, and I'll come back and multiply. This is 6 times 9x squared times 4 because of the 2 squared, and I'll come back and multiply. This is 4 times 3x times 2 to the 3rd, which is 8. And then the last one is 1 times 2 to the 4th, which is 16. Then when I go back and multiply, I'm finished. So 1 times 81 is 81x to the 4th. 4 times 27 times 2 is 216. And then we've got an x to the 3rd variable. 6 times 9 times 4, again is 216. X to the 2nd. 4 times 3 times 8 is 96x. And then 1 times 16 is 16. So if I take 3x plus 2 raised to the 4th and use Pascal's triangle to expand, I get this polynomial for my final answer. Okay, we're going to look at another one. And this one is example 5. Example 5 says use Pascal's triangle to expand x minus 4y to the 5th. So some things that are a little bit different on this one. I got a subtraction symbol, so we're going to look and see what to do if you have a subtraction symbol. I have variables in both spots, but I only have a number on my second term. Because of the 5th power, I go and I look at Pascal's triangle, 5th row. And I will use these numbers for my coefficients. 1, 5, 10, 10, 5, and 1. So I want to write those down. I have 1, 5, 10, 10, 5, 1. Notice I put me some space because I know I'm going to walk a term down and walk a term up. So I'm going to start with the x, and that'll be x to the 5th, x to the 4th, x to the 3rd, x to the 2nd, x and no x. And then I walk this one up. So I'll start here, negative 4y to the 5th. This will be negative 4y to the 4th. This will be negative 4y to the 3rd. Negative 4y to the 2nd. Negative 4y to the 1st. No 4y. Now I usually don't take the negative along with it because when a binomial has a minus sign in the middle, it just means that signs will alternate. So I usually don't even pay any attention to the negative. Like this term right here, if you take a negative and you raise it to the 3rd power, it's going to be negative. So there should be a negative out in front of that term. So you can take the negative along with you, or you can just know it means to alternate your signs. So I'm going to go through cleaning these up, raising to powers. So this will be 1x to the 5th. Then the next one will be minus. And then I have 5 times negative 4, so that's why it's minus 20x to the 4th y. This one gets squared, so when you square negative, you get positive, so that's why that's a plus sign. And then this is negative 4 squared is 16. So 10 times 16 is 160. X to the 3rd, y to the 2nd. I know my next term will have a minus sign because it goes positive, positive, negative, positive. This next one should be negative. Negative 4 raised to the third is negative, so that's why this term is going to be a minus in front of it. And then that's 64. So 10 times 64 is 640. I have x being squared and y being squared. On this next one, when you raise a negative to the fourth, it'll be plus, but we know that because the signs are going to alternate. Negative 4 to the fourth power is 256 times 5 gives me 1,280 x y to the fourth. And then the last term is, since it went positive, negative, positive, negative, positive, I know this will be negative. 1 times 4 to the fifth is 1,024, so this will be 1,024, and then you have y to the fifth. So when you take x minus 4y and you raise it to the fifth power, you get x to the fifth minus 20x to the fourth y plus 160 x to the third y squared minus 640 x squared y squared plus 1,280 x y to the fourth minus 1,024 y to the fifth. There's my final answer. So we looked at the fifth row of Pascal's triangle. We took our first term and walked it down, x to the fifth, to the fourth, to the third, to the second, to the first. We took the 4y, the second term, started at the end, walked it up. We said 4y to the fifth, to the fourth, to the third, to the second, to the first. One of the common mistakes is students forget to raise both of those to the power. The negative 4 gets raised to the power and the y gets raised to the power, for example. This was an example 5. This was example 2. Sorry. Okay, then we are going to go to example 3 and 4. And in examples 3 and 4, we're going to use the binomial theorem to expand. So we're going to be doing the same thing, but we're going to be using binomial theorem, which uses a combination formula. So you probably did combinations in Algebra 2, but it's been a while. Your combination formula, so you're taking n things and combining them r at a time, is n factorial over n minus r factorial r factorial. Factorial means to multiply that number times everything that comes before it. So for example, 5 factorial is 5 times 4 times 3 times 2 times 1. And that's 120. You have this key in your calculator under your probability button, math menu, so it can do combination of n things taken at r at a time, or you can use the formula. So the way we'll use this formula when we are expanding binomials, if I have a binomial raised to the 7th term like we did in the first example, this 7 is our n, and then whatever term value we're interested in will be our r. Actually, our r will be that term minus 1. Because when you expand something to the 7th power, you actually get 8 terms. So we'll subtract 1 to find r. Okay, let's look at our example 3 then. So on example 3, we ask for the 5th term. So I don't have to expand the whole thing, it just wants the 5th term. plus b to the 7th. So instead of using Pascal's triangle and going down and back up, all I have to use is the combination formula. So my n is 7 and my r is 5 minus 1. So my r is 4. So I'm going to do a combination of 7, choose 4. I could just put that in my calculator, or I could say 7 factorial over 7 minus 4 factorial, 4 factorial. So that's 7 factorial over 3 factorial, 4 factorial. Remember, factorial means to multiply, so I'm going to say 7 times 6 times 5 times 4 factorial. I'm going to stop there. 3 factorial is 3 times 2 times 1, and then that 4 factorial cancels with the 4 factorial. 3 times 2 times 1 is 6, and so that cancels with the 6 on top, and I get the combination of 7 things taken 4 at a time is 35. Remember, this is the 5th term. We could have got this from looking at Pascal's triangle. So if I go back to Pascal's triangle and I'll look at row 7, so right here, and I count over to the 5th term, 1, 2, 3, 4, here's the 5th term. I can get 35 that way too. So this 35 is the same thing as the combination of 7 things taken 4 at a time. Binomial theorem, Pascal's triangle, same thing. All right, so we're not finished yet. The 5th term then would be 35. And then I would take my first term and my second term. My second term would be raised to the 4th power because it's your r. And remember that these have to add up to 7, so this is n minus r, which is 3. So here is my 5th term. Could have gotten it using Pascal's triangle as well. Let's do another one of those. So example 4. Example 4 wants us to find the coefficient for x7, y squared. So it wants to know what number goes in front of that. And the binomial is 4x minus 3y to the 9th. So from this information given to me, I know that n is 9 and r is, looking at this, the second term is raised to the 2nd, so my r is 2. Alright, so when I'm using the combination formula, combination, 9 things taking 2 at a time, I say 9 factorial over 9 minus 2 factorial, 2 factorial. So that's 9 factorial over 7 factorial, 2 factorial. Notice 7 here, 7 here, 2 here, 2 here. 9 factorial is 9 times 8 times 7, and I'll stop there because I know there's a 7 factorial on the bottom, and then 2 factorial is 2 times 1. So the 7 factorials cancel. 2 times 1 is 2, goes into that 4 times. So the combination is 36. Not my final answer though, because remember, 36 is what we would have got from Pascal's triangle. I take my first term, which is 4x, and I raise it to the 7th. And then my second term, which is negative 3 I'm going to raise it to the second power. So then this is 36 times 4 to the 7th power gets raised to the 7th power. Negative 3 gets raised to the 2nd power, and I multiply all that together, and I get 5,308,416 x to the 7th, y to the 2nd. And there's my answer. Now, if I had used Pascal's triangle, I would have had to use row 9. When we made them out, when I made it out earlier, I only made it out to the 7th row. But remember, you can just keep generating those rows by adding the numbers up above. So, using this combination formula is using the binomial theorem. And then the other way is using Pascal's triangle. Okay, so that takes care of our examples 1 through 4. And your assignment for this week is page 633. You're going to do 2 through 26 even. And those problems are like examples 1 through 4. Email me if you have any questions. This is the last section we're doing in this unit. We'll have a review and we'll have a test to finish out our year. All right, go and do Pascal's triangle and the binomial theorem. Good luck, guys.